It's still used today to predict major events like the arrival of the monsoon.
But get this, there's also a really fascinating botanical side to natural forecasting. Take pine cones. Their movement isn't just random. It's an ingenious natural mechanism driven entirely by environmental humidity. Pine cones actually close up super tight in humid, damp conditions to protect their seeds from rotting. And conversely, they open up wide in dry weather to release those seeds, ensuring they spread when the weather is perfect for catching a ride on the wind. They're basically nature's very own humidity sensors.
Section 3. The elements of weather. This is where we start measuring the atmosphere. So, why do we need scientific tools if we have nature? Well, the problem is subjectivity. Imagine a phone call between Krishnan, who lives in the warm coastal city of Chennai, and his friend Amir, up in the snowy mountains of Kashmir. If it rains in Chennai and the temperature drops just a bit, Krishnan might say, "Man, it's gotten really chilly here." But how does Amir interpret that? What feels cold to Krishnan might honestly feel like a pleasantly warm summer day to Amir. Without a standardized way to measure things, they literally cannot understand each other's reality. To solve this exact communication problem, and to actually predict the weather precisely, scientists had to establish some common ground. Meteorologists focus on 5 core elements: temperature, precipitation, atmospheric pressure, wind, and humidity. By monitoring these specific factors objectively, we move completely past subjective feelings and can begin forecasting the weather on a global scale with incredible precision. And that brings us to Section 4, Tools of Meteorology. Let's look at the gadgets used for forecasting. First up is temperature, which is simply how hot or cold the atmosphere is. Now, we use thermometers to measure this ambient heat. While you might be picturing that old glass clinical thermometer from science class, today's meteorologists use incredibly sophisticated, mostly digital instruments to record data non-stop. This lets them gather vital statistics, like the mean daily temperature, which is just the average of the day's high and low, and the temperature range over a 24-hour period.
Let's see how that data actually works in practice with some real temperature readings from a city in Madhya Pradesh over the course of a week. If we want to find the temperature range for a specific day, it's super easy. We just subtract the minimum temperature from the maximum. Take March 3rd as an example. The maximum was 32 degrees Celsius and the minimum was 18. So the temperature range for that day was 14 degrees. Tracking these ranges day after day helps meteorologists spot much larger climatic trends. Our second core element is precipitation. Now, it's really important to clarify that precipitation is not just liquid rain. It's actually defined as any form of water that falls from the sky. So yes, that includes rain and snow, but also sleet, which is basically partly frozen rain, and hail, those solid, hard balls of ice that can sometimes drop down during really